Alright, let's do this review. So it says, how many sides does each polygon below have? It says triangle, so that's 3. Decagon, like a decade, is 10. Pentagon, like the government building, 5. Heptagon, that's the hard one, right? That one's 7. Nonagon, non sounds like 9. Nineagon. Hexagon has an X. 6 has an X. Dodecagon, I think of dose, I think of 12. Quadrilateral is 4. Decagon, I think of uno, it's 11. Octagon, like an octopus, is 8. Alright, so we got our formulas. We got sum of interior, one interior, or each interior, and then one exterior, or each exterior. Those are your formulas, so find the measure of one interior. Alright, so I'm going to use 180 times n minus 2 divided by n. And then n is 1, 2, 3, 4, 5, 6, 7, 8-sided figure, right? So 188 minus 2 divided by 8. We get 135. Is our answer there? Number 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11-sided figure. So we'll do 180. 11 minus 2 divided by 11. We get let's actually hit Control Enter. We get 147.27. Don't miss out on number 4 and 5. They're kind of small, but they tell you the n, the number of sides right there. So again, it's 180, 17 minus 2 over 17. We get Control Enter 158.82. And then a 23gon. Wow. Alright. Press Control Enter. Alright, for a 23gon, we get 164.35. Okay, so we got all those 1 interiors. Now it says 1 exterior. Remember, that's 360 divided by n. So we're going to count these up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10-sided. So 360 divided by 10, you know what that is, 36. 2, 3, 4, 5-sided figure. 360 divided by 5 is 72. Alright. A 14gon has 14 sides, so 360 divided by 14. Might have to use the calculator for that. We get 25.71. And a 20gon, 360 divided by 20 should be 18. These are all degrees for one exterior angle. So remember, an exterior is on the outside of a polygon. Alright. Sum of the interior angles. We're going to use n minus 2 times 180. Again, using our formula. So 1, 2, 3, 4, 5, 6, 7. 7 minus 2 times 180. Or to use the formula that's on the front of this sheet, it's 180 times 7 minus 2. Doesn't matter if the 180 before or after, you get the same thing. 900 total degrees on the inside. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 180, 12 minus 2. 12 minus 2 is 10, so it's 1800. 1, 2, 3, 4, 5, 6. 180 times 6 minus 2. Okay. $720. 180 times 35 minus 2. And while we're at it, 180, 52 minus 2. Alright, so we got 5940 and 9,000. Alright. So, you'll have the formulas for that. You'll be able to do that. The polygon below is irregular. Irregular. Meaning not all the angles are equal, so don't assume that they are. Using your knowledge of interior and exterior angles, find A, B, C, D, E, F. Okay? So, some of these are easy to find. Okay, first thing you want to do, let's see here, first thing you want to do is find all the supplementary angles. What is supplementary? Well, anything that makes a straight line, these are linear pairs, they add up to 180. So 180 minus 93, okay, is 87. So angle A is 87. Easy. Same thing here. Straight line is 180. So 180 minus 130 is 50. So B on the outside is 50. Okay. C, again, makes a straight line. 180 minus 67 is 113. So C is 113. Same thing here. Straight line. Makes 117 in D make 180 degrees. 180 minus 117 is 63 degrees. Great. Now, F and E. Okay, we're missing something. So I'm gonna help you out with the second step, okay? So you want to add up your exterior angles. And remember, since your exterior angles add up to always 360, you take that number and you subtract from 360 to get the missing exterior angle, which is F. Okay, so let me put some arcs on this. 93, 50, 67, and 63 are all exterior angles. And I'm missing F. So let's add up the 4 I know. So 93 plus 50 plus 67 plus 63. 273. 15, 21, 27. Yeah. All right, 273. So I'm going to take that and subtract it from 360 so I can get this missing exterior angle F. Okay. So I get 87 degrees for angle F because I know my exterior angles always add up to 360. That's something we got to know. And then last but not least, to figure out E, these are a straight line. They make 180. So 180 minus 87 gives me 93. So E is 93 after all. Okay. So a lot of it's just subtracting from 180, and then take all my exteriors, add them up, and subtract from 360, because the exterior angle sum is always 360. All right? Draw a picture. We can do it. All right, so a kite. Now, if you do this, that's kind of all right. But remember, one pair of opposite congruent angles, consecutive congruent sides, consecutive congruent sides. Very important, okay? All right, square. What makes a square square is not just equal sides, but also equal angles. And every side should have the same tick mark for a square. Okay, a rhombus, other people like to call it a diamond shape. Doesn't matter if you draw it this way or sideways. The main thing we know about a rhombus is every side is equal, but the angles are not all 90, necessarily. Rectangle. So again, if you draw that, that's cool, but make sure you label. We know all the angles are right, opposite sides are equal, but they're not all equal to each other. Parallelogram. Everyone's favorite, because I am a parallelogram, right? So, parallel sides, right? Opposite angles are equal. Consecutive angles add up to 180. They're supplementary. These are parallel and equal. These are parallel and equal. It's hard to fit that in there. Trapezoid, remember, it has one pair of parallel sides, and the other side, nothing is necessarily equal. Okay. A right trapezoid has a right angle, parallel sides. Okay. Isosceles trapezoid has to have two equal sides, kind of like an isosceles triangle. Okay, so I kind of drew that too long. So equal, equal, parallel, parallel. Okay, so that's what isosceles would look like. That's great. All right, we got a parallelogram. We need to label. If you don't label, it's going to be hard to do these. Just saying. So you need to label. So it says AB equals 6. So I need to label. AB equals 6. Put a 6. AD equals 3. Put a 3. It may not be drawn to scale, but that's all right. So I got 70 degrees here. Now I need to find some other stuff. Now let me remind you, for a parallelogram, opposite sides are equal, opposite sides are equal, opposite angles are equal, right? And then opposite angles are equal. So, if this, I'm going to fill stuff in before I answer this question. Angle D is 70. So what else do I know? Across, these are equal. So angle B is also 70. The question is, what is angle C? So remember, angle D and angle C are consecutive. That means they add up to 180 degrees. They're supplementary. So 180 minus 70 is 110. So C is 110. And that's across from A, which has to also be 110. Okay. Now those angles I could fill in. Angle A, 110. Angle B, 7D. And remember, opposite sides are congruent, so if AD is 3, BC is 3. If AB is 6, DC is 6. Okay? So BC3, DC6. Alright. Let's label. Given y is 2x minus 3, given angle Z is x plus 9, solve for x. Alright. Well, we can do that. The question is, are those two angles equal, congruent, and equal in their measurement, or are they supplementary? And since these are consecutive, since y is obtuse and z is acute, since they do not match in this situation, since we know it's a parallelogram, they are supplementary. So don't set them equal, add them up to 180. 2x minus 3 plus x plus 9 equals 180. Please notice the x's are on the same side of the equal sign. So we are going to combine like terms. 2x plus 1x, 3x. Negative 3 plus 9, 6. Equals 180. And now I have a two-step problem to get rid of my loner first. Minus 6, minus 6. 3x equals 174. And then I need to divide by 3. And then x will be equal to 58. Yeah. So x is equal to 58. Great. Then it says something about these sides. XW, okay, is 5a plus 4. So and then YZ is 7a minus 20. Now, these are opposite sides and they're congruent. So I'm going to put an equal sign between them because I know they're equal because they're congruent sides. And then I'm going to solve for A. So, look at that. I already have it set up. So let's go ahead and solve this. The A's are not on the same side. So I do not combine my terms. I get rid of the smaller a, which is 5a. So minus 5a, minus 5a. Bring down 4 equals 7 minus 5, 2a, minus 20. And on the right side, my loner is minus 20, so I need to add 20 to both sides. And I'm going to have 2a equals 24. I must divide by 2 to get 12 equal sign a. And that gives me a. Alright. Next page. The following is a rectangle solved for the missing variables. So, we've done something like this before on the 26th, the quadrilateral properties practice. Okay, so let's set each of these angles equal to 90, right? So W equals 90. All that means W equals 90. That's easy, okay? Let's try the next one. 5x equals 90. So you're going to have to divide by 5. And you'll get x equals 18. So x equals 18. Let's try the next one. 2z equals 90. Divide by 2. So z equals 45. Cool. And then 3y equals 90. So I have to divide by 3, and I get 30. So again, It's very important. When you see rectangle, you know every angle is 90, so just set them equal to 90, okay? Let's do our sides. Actually, real quick. Right angle, right angle, right angle, right angle. So for sides, 4b equals 8. Divide by 4. B equals 2. Okay. This one will be a little harder. These opposite sides are equal. So 5a minus 2 equal sign 12a minus 23. I need to get rid of my smaller a, so minus 5a minus 5a gives me negative 2 equals 7a minus 23. Got a two-step problem, so I got to get rid of the minus 23. So I'm going to add 23, add 23. It's going to give me 21 equals 7a. Dividing by 7, sorry, I did write small, a equals 3. Okay. Cool. 27, find the area and perimeter of the following isosceles trapezoid. Okay, so the height, so to figure out this height, you're going to have to use Pythagorean Theorem. Okay? Now, I'm telling you, you're not going to have one this difficult on your test. Okay? But, check it out. If that's 6, so between here and here is also 6. So what do I need on each side here and here to add up to 16? Well, I need 10 more, so it's going to have to be 5 and 5. 5 plus 6 plus 5 is the total 16, right? Alright, if that's 13, then this over here is 13. And you can do Pythagorean Theorem to find the missing leg here. You could do 5 squared plus x squared equals 13 squared. I'm doing this real quick because we've technically done this before. The square root of 144, hopefully you know that by now, but x equals 12, okay, so this height is 12, using Pythagorean Theorem. Now the area, I'm going to do a blue, the area formula is base 1 plus base 2 times the height divided by 2. 16 plus, not times, 16 plus 6, my two bases, times the height of 12 divided by 2. So let's do that. 16 plus 6 times 12 divided by 2. We get 132 units squared for our area. And the perimeter, I'm just going to add up. So that was my area. And then for my perimeter, I'm going to add up my 4 sides. 16 plus 13 plus 6 plus 13. And I think that should be 48 if I'm not crazy. I might be kind of crazy. Let's try to, let's just do this. 48. Maybe I'm not crazy. I mean, I'm a little crazy. Those would not be square units. Those would be regular old units, okay? All right. Now we're going to get into area and perimeter practice, which we can do by using our formulas. Area and perimeter. Area is base times height divided by 2. .4. This is miles, so not drawn to scale. Miles squared. And the perimeter, we're just going to add up 11 plus 10 plus 8. Do not add the height of 9.6. You get 29 regular old miles. This one is sideways, so the base is 12, the height is 6.7. 12 times 6.7 divided by 2. 40.2 miles squared. Add up all your sides. Get 30 miles. Okay, for rectangles, hopefully we know it's length times width. 10.3 times 7.1. 73.13 miles. It's a lot of miles. Squared. And then perimeter. Remember, each side that's opposite on a rectangle is the same. So 10.3 plus 10.3 plus 7.1 plus 7.1. 34.8 miles. Okay, same thing on 31, except it's a square. So the area is 9.3 times 9.3. Or you could write it as 9.3 squared. Okay, it's 86.49. Inches squared, and the perimeter is 9.3 plus 9.3 plus 9.3 plus 9.3, or just 9.3 times 4, because they're all 4 the exact same, because it's a square. So we'll do that. 9.3 times 4 is 37.2 inches. Okay. Trapezoid, so remember for area it's base 1 plus base 2 times the height divided by 2. Oops, don't forget the parentheses. So it's 3.9 plus 10.9. Remember it's plus, not multiply, and then you multiply it by the height, which is 3.4, and then we divide by 2, 25.16 inches squared, right? And then for perimeter, add up the 3 sides, not including the height. That's an isosceles trapezoid there. We get 24.6. Keep messing up my colors here. Inches. Okay, so same thing over here. Base 1 plus base 2 times the height. Now the height, since at the right angle, is 2, and then divided by 2. Okay. Spoiler alert, it's 2.6 miles squared. And then the perimeter, we're going to add that all up. 2 plus 2 plus 0.6 plus 2.4. It's going to give us 7 miles. That's some mental math, hopefully. Okay, let's remember for polygons, big A area is little a apothem divided by perimeter divided by 2. So my suggestion is to find the perimeter first. So the perimeter is 7.7 times 8. 7.7 times 8. $61.6 That's not an area, so it's regular units. My apothem is 9.2, so let's do that. 9.2 times 61.6 divided by 2. 2. So 283.36. That would be units squared. Number 35, again, we'll start with perimeter. We got 16 times 5, which is 80 units. And then our area is going to be apothem, which is 11 times 80 divided by 2. Okay, that should give us 440 units squared. Okay, now this one, we're going to have to use Pythagorean Theorem to find the missing apothem. Half of 6 is 3. So we can do 3 squared plus 10 squared equals, nope, that's wrong. Yeah, that's right. A squared, the apothem. We'll call it x squared. Nope, that's still not right, my bad. 3 squared plus a squared equals 10 squared. So we get 9 plus a squared equals 100. We subtract 9. We get a squared equals 91. And we do the square root of 91. So the square root of 91, 9.54. So the apothem is 9.54. So for perimeter, we can do 6 times 6 and get 36. For area, we can do apothem, 9.54 times perimeter, 36, divided by 2. 171.72. Those would be units squared. Okay, on 37, again, it's Pythagorean Theorem, so ABC. Subtract and then we square root. So the whole length, if this little half is 8.76, then the whole length is 8.76 times 2, which gives us 17.5. So to get the perimeter, we're going to do 17.5 times 6. 105.14. This is not an awesome problem. Regular units. And then the area is the apothem, 8.2, times the perimeter, 105.14, divided by 2. So ugly. 431.07. That don't seem right. Alright, back it up. I guess I was. Yep. Oh, except it's not 8.2. Yeah, it is. 431.07. That is the ugliest problem I've ever seen in my life. Alright, then you got these bonus problems that you can try. And then on the back we have composite figures. So this tick mark is 5, so this tick mark has to also be 5. So we can find the perimeter if we add up all the sides. So we got 5 plus 7 plus 6 plus 5 plus 10 plus 15. So we got 12, 18, 23, 33, 48. Perimeter is 48 inches. Now the area is going to be 3 areas. So for this, it's going to be 6 times 5 is 30. For this, it's going to be, now if this whole thing is 10, then this length would be 10 minus 6, which is 4. So this will be 15 times, not even 15. So this bottom length right here is not 15. 15 goes all the way across. So for just this little section, it's 7 plus, and this is going to be 5. So together, this whole thing is going to be 12. It's kind of tricky. You can do it. 4 times 12 equals 48. And this right here is base times height divided by 2. So if this thing is 12 and the whole bottom is 15, then that makes this 3. So base is 3, height is 4. So 3 times 4, and then divided by 2, since it's a triangle, it's going to give me 6. So I got my 3 areas. Actually, let's rewrite that because it looks like garbage. Here we go. 3 times 4, kind of garbage again. 3 times 4 divided by 2 equals 6. Okay, so my areas, my 3 areas that I just calculated are 6 plus 30 plus 48. And that's going to give me, let's see here, 54, 84, right? Hopefully. Yeah. 84 what? Inches squared. Alright, another one. So we got a little square, a rectangle, and a triangle here. So the perimeter, so this bottom length is going to be 4 plus 6, 10. And now we can add up all these sides for the perimeter. So perimeter equals 4 plus 4 plus 6 plus 6 plus 2 plus 6 plus 10. 10. Looks like garbage again. I love it. Plus 10. Alright, so 10, 20, 8, 38, 48. Perimeter is 48 centimeters. And now let's find these areas. So this is going to be 4 times 4, which is 16. This is going to be, now this whole length is 6 plus 4. So it's going to be 10 times 6. So 10 times 6 is 60. And then what is this little length right here? If this is 2, and the whole thing is 10, then this is going to be 10 minus 2, 8. So this is going to be base times height divided by 2, 8. Garbage. Try again. 8 times times 6 divided by 2, 24. Okay, so I got my three areas. So my areas for the square are going to be 16 plus the rectangle is going to be 60 plus the triangle is going to be 24. It's going to give me 40. It's going to be 100 centimeters squared. Cool. And then, alright, so this is like a trapezoid. Take away a rectangle. You could cut it into, like, probably not. Yeah, I'll just do trapezoid minus rectangle. Okay, so for the perimeter, we're going to omit this because it's not going to be on your test. We haven't gone over the subtraction stuff, and this review is too long, in my opinion. So, don't worry about that one. On 43, let's make some rectangles here. Alright, the whole thing is 15. 7 plus 5 is 12, so this has to be 3. Okay, now off to the side here, it says 3. So that's 3, right? So for perimeter, we know every single side so far, so we add them up. P equals 3 plus 7 plus 6 plus 3 plus 6 plus 3 plus 3 plus 15. And we get 19, 25, 28, 31, 46. Okay, so we get 19, 25, 28, 31, 46, yeah. So 46 meters. Let's find these areas. This is going to be 3 times 7 equals 21. And then this is going to be 3 plus 6. So this whole side is 9. 9 times 3 is 27. This is 3 times 3, which equals 9. So area is going to be 21 plus 9 plus, that's not true. Oh yeah, it is. This 9 plus 27. So that's going to give us 57. And again, my units are meters, but this time it's going to be squared. Alright, that's the review.